Hi students, welcome back to that is your channel Physics by Imagination. Dear students, in the previous class we had understood clearly in part 1 and part 2 about electromagnetic induction, what they have prescribed in the CET syllabus. Today we are going to discuss about 7th chapter, alternating current. Okay, so what is alternating current? So the current which changes its direction and magnitude. So this is called alternating current. So I can draw it as a current which changes direction and magnitude. So here current is maximum, here minimum. So along with the time, and this is called alternating current. So alternating current, we know that we have produced in the generator, that we had converted that is mechanical energy into electrical energy. So now here this is called peak value of current. The maximum current we can see when it converts mechanical energy into electrical energy, that is called peak value, that is given by I naught. And here instantaneous current is given by, that is I is equal to I naught sine omega t. Similarly, the instantaneous voltage is given by V is equal to V naught sine omega t. Here omega means that is angular frequency, which discussed in the electromagnetic induction chapter. So now here this is will be T by 4 and this is 3T by 4. So this will constitute one wave. So now I am going to define frequency and time period of AC. What is frequency? The number of cycles made by of an AC in 1 second. So generally frequency means the number of oscillation per second is called frequency. Now number of vibrations per second. So it becomes 1 by T. If one vibration in 1 second means it is 1 by T. This is the formula for frequency. Time period means the time taken to cover one complete wave, that is called time period. Remember children, frequency which is inversely proportional to time period. And generally here the current will be about 5 amperes and frequency will be 50 hertz for this AC circuit. They may ask you in the CET. And here very important point, here alternating current for lower consumption appliances we are using 3 to 5 amperes. And here means like refrigerator, fridge, we are using electrical water heater, iron box, that is 10 to 15 amperes. So this is all about alternating current. I hope you understood. After understanding this, let us move for next topic, that is current passing through the resistor, current passing through the inductor, current passing to the capacitor. So now here what happens if I pass the voltage in the resistor, in the inductor, in the capacitor. So before that, let us know some basic definitions. So first one is peak value. So what is peak value? It's very simple. Peak means what children? That is the maximum value. The maximum value of voltage and current, that is called peak value of the voltage. And maximum voltage means peak value of the voltage. Maximum current means peak value of the current. Okay. So this peak value is nothing but maximum value. So now here second one is, that is mean value. So you should know these basic things. Mean means what? The sum of the all the values of the instantaneous current. I have given equation already. I is equal to I naught sine omega t. I is equal to I naught sine omega t. This is the expression for instantaneous current. So the current will be given at instant time, that is called instantaneous current. Okay. The sum of the all the instantaneous values taken over either of the AC cycle, that is called mean value. That is called mean value. So now here let us get the relationship between mean value and peak value, very important for CET. So dear students, that is mean value is equal to 2 by pi into peak value. Or we can do, that is peak value is equal to what we can write, that is mean value into pi divided by 2. You can do cross multiplication. So now here, if I divide this, we know that 3.142. So you will get that is 0.636. If you divide and simplify, very easy to remember for CET. And into peak value, it may be current or it may be voltage. So it's not divide R. It may be current or voltage. Or you can write this is voltage. I'll write 0.636 into I naught. This is very useful to solve the problems. Please note down. So after understanding this, let us go for RMS value. So RMS value. So what is RMS values? The sum of the squares of all the values of instantaneous current taken over a cycle. That is called RMS value. Okay. So this RMS is given by peak value divided by root 2. Peak value divided by root 2. Very important. So peak value means it may be voltage or current. In terms of voltage means V naught by root 2. In terms of current means I naught by root 2. And if I simplify, this root 2 means 1.41. So 1 over 1.41, if it divides, you are going to get that is 0.706 nearly, that is V naught, or we can write that is I naught. This is all about basic things about peak value, mean value, RMS value, and that is relationship between RMS value, peak value, mean value and peak value. Please note down, very important for CET. So after understanding this, let us move forward. That is what happens if I pass, that is voltage. I have connected a resistor to the AC source. This is symbol for AC source. Let us understand what happens when I pass to the resistor, inductor, capacitor. So first I will take, that is I have passed it to resistor. You know that resistors, it is going to oppose the flow of current. Okay. So now let us take that. Very simple. So here we have given, that is V naught sin omega t. What we are giving the potential difference. So the input we have given that V is equal to V naught sin omega t. Very simple, children. This is called equation 1. In the circuit R and current is passing. So combinedly I have drawn. You forget about L and C. Only remember this circuit. Easy to remember. And now this is called, V naught is called peak value of voltage, and omega is called, that is angular velocity of the coil, that is theta by t. Now what happens here? We know that according to Ohm's law, V is equal to I into R. I is equal to V divided by R. Now I want to get the value of I. So then what happens? I is equal to V. V means V naught sin omega t. V naught sin omega t divided by R. So V naught by R is equal to I naught, that is called peak value of current. If I want to find peak value of current, I should know this is V naught by R, resistance, and that is peak voltage. Now I is equal to I naught sin omega t. So by using this relation, we can see that here it is resistor. In the case of resistor, when we pass voltage, it is free from induction effect, because current will be moving in the opposite directions. Then what happens here? There is no phase difference. There is no phase difference. So when there is no phase difference means here it will be in phase. It will be in phase. It will be in phase. So that is phase difference is equal to 0. So there is no phase difference in the current and voltage when we pass voltage through the resistor. So that we can see graphically. This is maximum voltage, peak current. This graph you should remember. Remember here, this is here, that is both VL and I will be same. No phase difference, that you remember. Please note down this. So after understanding this, Let us understand that. Very simple. What happens if I pass voltage to the inductor? So same thing. The given equation is V is equal to V naught sin omega t. What we are going to provide the potential difference through the inductor. So here, what is inductor? The students, very important point I am telling now. You should remember that. That is, it has I inductance and negligible resistance. I inductance, negligible resistance. Here resistance was there, but here what is there? I inductance. Write down. I inductance means it conducts the current nicely. I inductance, but negligible resistance. So I can take nearly 0 ohm. Now we know that according to Kirchhoff law, that is second voltage law, the sum of the EMF is equal to product of current and resistance. If I apply to this circuit, I'll get that expression as very simple. That is V plus E is equal to, means we are going to find self-induction, the process of producing EMF and passing voltage in the same coil or current in the same coil. Now I into R. This is 0 because very negligible resistance is there. So what happens here? That is V plus E is equal to 0. We know that electromotive force is equal to, that is self-induction. That is EMF is equal to minus L into di by dt. If I substitute, that is I'll get minus L into di by dt. I will send this side. That is V is equal to L into di by dt. Very simple. I have sent to, that is RHS side. Now what is going to happen? Dear students, I want to find current. So di is equal to V by L into dt. So now here, what I am going to do, substitute the value of V here. So it becomes di is equal to, that is V naught sin omega t divided by L. So dt. Now let us go for, that is integral calculus. Integrate. So we'll get integration. What do we get? Very simple. That we are going to get that integration of di means, that is I. So this is V naught divided by L. I am going to take constant terms outside. Then integration of sin theta minus cos theta. So it becomes what, children? That becomes minus cos theta, cos omega theta divided by omega. So I is equal to V naught divided by L omega. This cos minus cos omega t nothing but what? That is sin omega t minus 90 degree. So this is V naught by LW is called I naught. Right, isn't I naught is equal to V naught divided by L omega. L means inductance. Now it means the voltage leaded by 90 degree. The voltage leaded by 90 degree. In the case of when I pass voltage through the inductance. This is the phase diagram. This is peak voltage, peak current. So you have to remember this graph very carefully, children. Okay, here see the voltage is going to be leading. So now here we will find reactance. So what is resistance? The opposition to the flow of current is called resistance. But reactance means the opposition of the current when we pass voltage. In the case of either inductor or capacitor, that is called reactance. Now what is going to happen? So that is reactance of XL is equal to, that is 1 divided by omega into L is there. So directly 1 by XL is equal to 1 by omega into L is there. So now here XL which is equal to omega L. I want to find inductive reactance. So now omega means what, children? That is 2 pi f, fundamental relation. So it means this inductive reactance is directly proportional to inductance and frequency. If frequency increases, definitely inductive reactance in the inductor will increase. So this is about inductor. So let us move to, after understanding this, please note down. We'll go for what happens when I pass this voltage through the capacitor. We know that what is capacitor, students? The ability of the charges stored in the when we keep the dielectric materials, that is capacitor. Now let us see what happens here. We have found that here what happens, phase difference is 0, but here phase difference is equal to 90 degree. What happens here? And voltage is leaded. Let us see what happens. So now here we know that this is the input voltage what we are going to give here. Now it becomes, that is, we know that capacitance of the capacitor, that is capacitor is equal to Q divided by V. Now I want to find what, children? I want to find current. I want to get the expression of current. So what I can do, that is Q is equal to C into V. Very simple, cross multiplication. You call this as equation number 1. We know that is steady current. The current will change. So expression for current is given by I is equal to dq by dt. So let us substitute this q value. So I is equal to d by dt of, so and what happens, children? Q is equal to C into V. Now d by dt of, the students substitute the value of V, that becomes V naught sine omega t. V naught sine omega t we got. Now V naught I'll take outside. V naught and C I'll take outside. I is equal to, it becomes V naught C d by differentiation we are doing. Before case we had did that is integration. Now this is sine omega t. So we know that differentiation of sin x means cos x. So which becomes, so it is going to become what, children? That is I is equal to V naught C. Here this is a constant term, will be multiplied into cos omega t. So this is nothing but what? This is nothing but peak current, peak value of current. So that is I naught is equal to V naught omega c. Dear students, what is going to happen now? I is equal to, it becomes I naught, this cos omega t can be written as sine of, that is omega t plus 90. Omega t plus 90. It means here current is leading. In the previous case, voltage were leading. So that can be represented by graph. That is, this is current we have find when we pass this voltage. Now see, your current is going to be leaded. And here phase difference is equal to 90 degree. We can easily remember, children, in the case of inductor, graph will be like this. This is voltage leading, current will be down. In the case of capacitor, we can draw like this. So that is current VL. So remember. So this is all about what happens when current passes through resistor and inductor and capacitor. So next class we'll discuss about what happens we passes through three the things simultaneously and about transformers. I hope you understood, children. Please, if you understand, please like it and share and subscribe. Thank you.